The second part of our analysis gets to the main research question. Namely, we want to know if reading scores differ for the different SES categories. So I start, as always, with a graph. And the graph that we're going to use, because we have one categorical variable, SES, and a quantitative variable, the reading scores, I'm going to use side-by-side box plots. So I write a little narrative here. Figure 2 illustrates how reading test scores are related to SES categories. From this, we can see that the central tendency of the reading scores in the high SES category outperforms that of the middle SES. Well, I haven't constructed figure 2. Actually, I did. You can see it here, but let's wipe that out. So I really am not ready to write anything beyond figure 2 illustrates how reading test scores are related to the SES categories. Now, we don't need this new page here. I did that when I created a PDF file, but we don't have to worry about page breaks when we're dealing with our previews, which are continuous, so I'm going to take that out. So, let's see, did I have a new page earlier? Yes, I did. Let me go ahead and take that one out too. Okay. So, let's see. It looks like I can do this with one command, and here it is. Boxplot is the function we're using. The first argument reads that reading score is a function of SES. Whenever you see this little funny squiggly, which is called tilde, tilde is read as a function of. So here we have students in the data set. We're going to take the reading variable as a function of the SES in the students data set. That is, we want to look at reading to see how that is related to or a function of SES. Now, I already told you about the limits that this will set for us on our axis. Now, how did I know to put 20 and 80? Let's go ahead once again and take that out of there for now, because normally what happens is I run it and then I go back and fix it so I get the axis to look the way I want it to. So I have an X and a Y label. So let's go ahead and run this. Here we go. And that's not too bad, actually, the way it is right now. But I wanted a little bit of extra, I think, in the bottom and the top. And so let's see what happens when I put in that command that I had in before. And that was this. So now if I run it, there it goes. It was fine the way it was first, but I sort of thought that looked a little cleaner with a little extra space at the bottom and top. If you don't do the limits exactly the way I like them, so in other words, if I like a little extra space but you don't, and so you don't put in this command, let's take it out again and look at it. Okay. So that your box plots actually look like this instead of exactly like mine. Let's talk about the point deduction for that. If you don't make your graphs to look exactly like mine, even if your graphs are set up correctly and giving the right information, there is a substantial point deduction. It is 0. You don't get any points deducted as long as your graph is set up correctly and tells the story. So if you do it like that and I do it like this, it's tomato, tomato, it doesn't matter to me. Okay, so let's look at this and see what it says. It looks like the scores go up. But how about spread? I like to not only focus on the middle of the distributions for low, middle, and high reading scores, or I'm sorry, low, middle, and high SES, but I'm looking at the distribution of reading scores conditioned within low, middle, and high SES. Not only do I look at the middles, these are the medians showing here in these lines, and I see it goes up, but I also want to look at the spread. And what I notice is that stays fairly constant. There's a little bit of more of a interquartile spread here from the first to the third quartile, this box here for high. But if you look at the full range, it's pretty close for all of them. So what I see happening here as we change SES is that the distributions are basically, as a whole, sort of shifted upwards. So from low, if we move to middle, it just shifts the distribution upward a little bit. And if we move to high, up a little bit more. Well, how much more? That's where descriptive statistics come in. The graph tells the major story, and that's why I like these. I like these better than statistics. Looking at the graphs. Now, granted, the graphs are made up of statistics, but don't try to read the statistics off the graph. Don't just look at this and say, oh, the median for low looks about maybe 47. No, we're going to provide descriptive statistics, which is, I think of it as a drill down of the graph. That is, your table of statistics should match your graph that you're using. So I need some statistics. And notice they're going to be conditional. They're going to be conditional on SES level. So I need statistics for low, for middle, for high. So let's do my favorite statistics here. My favorite statistics, and I have them right down here, are to do mean and standard deviation, and then the 5-number summary: minimum, first quartile, median, third quartile, and maximum. Now let's talk about this tapply command. This is very useful if you're going to look at statistics separately for separate groups, because what this will do is it will calculate the statistic for the first variable I list here as an argument, read, for each level of the second variable, SES, and the statistic it will calculate is based upon the function you put here, third, which is the mean. So this says, please give me the mean of reading for each SES. And I'm going to store that in mean. So if I run just this line, let me do that. And if I then type up here in the console window, mean, you'll see it gives me the mean for low, middle, and high. So I'm going to do that for standard deviation, minimum, first quartile. First quartile, let's take a look at that function. That function is the quantile function. And the quantile function, we tell which quantile, and that is we want the one that is the 25th. So we put P of 0.25. We want 25% of the area, or a proportion of 25 below this quantile. Then we have median, third quartile, and maximum. Then when I'm done with all that, I C-bind them together. Let me get rid of this round function for just a minute. You probably can guess what that does, but let me get rid of that and show you what we would get here. And here it is. I didn't hide it in the output because this time there's so many statistics. I don't want to list all these in the narrative. I want to put them in a table. And so there's so many statistics here. And what I find is that that's a little bit unwieldy. I mean, look at this. The standard deviation for low, 9.342987. Who's going to remember that? So I went ahead and put in a rounding. And if I put in a rounding, it will get rid of all those decimals which I don't need and give me a nice clean table. No one's going to remember anything for the standard deviation beyond 9, so I'm just going to give 9. Now, if you want to round it with 1 decimal point, we could have put in here a comma 1, and then we would have gotten a single decimal point in our table, and 2 decimal points, and so forth. What I always do is I look at how precise these numbers are. So if we're dealing with small numbers, 0.00032, I'm going to leave that 32 in there. But when we're dealing with numbers where really we get the major message, just rounding to an integer, then I'll go ahead and round to an integer without any decimal points. And that's what I've done here. Okay, so now what I have is a table that I've labeled with a caption, and the table's down here. I've separated all my figures and tables, by the way, with horizontal lines, which in R Markdown you can make with 3 asterisks. If you don't have that cheat sheet for R Markdown, you need to get it, because these things are all on there and you can easily look them up. So let's see what it looks like when I look at the preview for this analysis. So here I talk about figure 2, and I give what the figure is showing me, that middle outperforms low and high outperforms middle. And then I show table 1 down here, and I talk about table 1, and I talk about what kind of change we have, what kind of difference there is between low, middle, and high. And I say that the change is pretty much across the entire distribution. So I focus as an example on the mean. The mean for students in the middle SES group is about 3 more, or you could say 4 more with the rounding, than it is with low, and about another 4 more or 5 more. See, I got these 3 and 5 before I rounded. I might, if I'm going to round to an integer, I might want to come back and change this and say, let me do that. Change that to 4 points higher and change this to 4 points higher. So let me do that. Let me make this consistent. Obviously, when I wrote this up the first time, I was looking to more decimal points. So let me just say the mean for middle is about 4 points higher than the mean for low, and the mean for high is about 4 points higher than the mean for middle. And now if I look at this preview, I have that all changed, and we're good. So we've now done the second analysis. 1 more to go.